Okay, we're going to be doing some matrix multiplication today. I'm going to leave the explanation as to why and how important these are to your A-level teachers, but I'm just going to show you the skill. So what we need to do here first is that this top row needs to be multiplied by this column here. So 7 times 4 is 28, 2 times 1 is 2, and then the bottom row multiplied again by the same column. 0 times 4 is 0, 3 times 1 is 3. So this matrix can now be simplified to 30 and 3. So that's a 2 by 2 multiplied by a 2 by 1 will always result in a 2 by 1 matrix. Okay, now we're moving on to a 2 by 2. Now what you might expect is that this might just simply be 2 times 4 is 8, 1 times 2 is 2, 0 times 1 is 0, and 3 times 5 is 15. If it was the case, it'd be fantastic, but unfortunately it's not. You have to do exactly what we just did then. A 2 by 1 multiplied by a 4 by 1. So this will give us the top left-hand number. 2 times 4 is 8. And then 1 times 1 is 1. So we get a 9 in that corner. Switching colours again, we're going to do this one again. And now by this column. 2 times 2 is 4. And then 1 times 5 is 5. And then we're going to do the bottom row by this column first to give us the bottom left-hand number. 0 times 4 is 0, 3 times 1 is 3. And then finally, bottom row against the second column will give us the bottom right hand number. 0 times 2 is 0, 3 times 5 is 15. So this matrix now becomes 9, 9, 3, and 15. So a 2 by 2 matrix multiplied by a 2 by 2 matrix will always result in a 2 by 2 matrix. Okay, finally, we're going to go to a bit of a problem solving matrix involving the identity matrix. Now, again, I will leave that for your A-level classes, but it's quite useful and quite important in solving equations as well, like when you get a bit more experience. So now, same again. That top row multiplied by this will give us negative x plus 6. Keep going with this one as well. 3 times y is 3y. Sorry, I messed that up, sorry. Negative 1 times y is negative y. And then 3 times z is 3z. Let's do this bottom row now. Negative 2 times x is negative 2x. And then 5 times 2 is 10. And then finally, negative 2 times y is negative 2y. And then 5 times z is 5z. Now, we are told it also equals 1, 0, 0, 1. Now what we can see from this now is that we've got values of x, y and z to work out, which we had in the first place. But we can see that this negative x plus 6 must equal 1 in this corner here. So negative x at 6 must equal 1. So quite clearly you can see that the x has to be 5. So this new matrix down here, this matrix up here has now got 5 and a 2, and we've got to work out the y and the z. Now we can see here that we've got negative y plus 3z equals 0. And then we've got negative 2y plus 5z equals 1. And what we have now is simultaneous equations. So if I multiply this equation by 2, you will see that becomes negative 2y plus 6z equals 0. And if I write the other one underneath it, you can see that if we take these away now, that's going to cancel off. 6z take away 5z is z. 0 take away 1 is negative 1. So z is negative 1. So now I've found z, I can pop it back in here. Negative y add 3z is 0. Z is negative 1, so negative y take away 3 lots of negative 1 is 3. So negative something take away 3 is 0. Well, this has to be plus 3, so y has to be negative 3. So we can complete the matrix. 5, 2, y is in the top corner, so that's negative 3, and z here is negative 1. Now realistically we should be checking these numbers to make sure they work in both equations. The 5 there, 2 negative 5s is negative 10, negative 10 add 10 is nothing, checks out. Negative 2 times negative 3 is 6, 5 times negative 1 is negative 5, 6 take the 5 does give us the 1. So we have found the missing values in this matrix up here.